to find the percentage composition of different compounds, or find the percentage composition of certain elements within a compound. So let's start by looking at what percentage composition is. It's all based off of a law known as the law of definite proportions. And essentially what it says is that if there's a compound that forms, the proportion in which that compound forms is going to be consistent. It's always going to stay the same. So that last sentence there summarizes this pretty well. When elements combine to form compounds, they do so in a definite proportion. Okay, let's take a look at a compound that might be familiar to us. So here is water. Water has a chemical formula of H2O. That means that in terms of mass, whatever amount of water that you're looking at always has 11% hydrogen and 89% of oxygen, right? And it's just a percentage value. And I'm sure that you have calculated percentage of different things before, and that same formula applies here as well. So in order for us to find the percentage composition of an element, you have to take the mass of that particular element and divide it by the total mass of that compound and multiply it by 100. Just like you would have calculated the percentage that you've gotten on a test. If you get 9 out of 10, you have to do 9 divided by the total marks, which is 10. 9 divided by 10 times 100%. All right, let's actually put this into practice. So the first example is asking us to find the percentage composition by mass of aluminum oxide, Al2O3. And my first step here is to find the total mass of the compound. And because we don't have any other information, we do have the molar masses of these elements. So we're going to go with that. So based off of the molar mass, I'm going to first find the total mass of this compound. So molar Al2O3. And again, I just look at my periodic table to find this. So aluminum has a molar mass of 26.98. So 26.98 grams per mole. And there are 2 atoms of aluminum here. So I'm going to put a little 2 there. Plus, the molar mass of oxygen is 16.00 grams per mole. And there are 3 oxygens there. Okay, so let's do this. So 26.98 times 2 will give me 53.96 grams per mole, plus 16 times 3 will give me 48. And when I add these two numbers together, I will get 101.96 grams per mole. So this is the total mass of this compound. All right, now I'm going to do the individual sections. So in order to find the percentage of aluminum, I would have to take the mass of aluminum, and again, we're accounting for the fact that there are 2 atoms of aluminum in this compound, and divide it by the total mass, right? So let's do this. So 53.96 grams per mole divided by 101.96 grams per mole times 100%. And when I do this, I will get 53.96 divided by 101.96 times 100 will give me 52.92%. Okay, and I'm going to do the same thing, but for oxygen, percentage of oxygen. Again, we're taking the number that accounts for the number of atoms there are there. So 48 grams per mole divided by 101.96 grams per mole, which is the total mass of this compound, or molar mass of this compound. So 48 divided by 101.96 times 100 will give me 47.07%. And there we go. So I've now found the percentage composition of aluminum and oxygen for this particular compound, aluminum oxide. All right, here's the next example. I think you should be able to do this by yourself. So take a second to pause, try it, and then play when you're ready to check your answer. So same thing as before, I'm going to start by finding the molar mass Na2SO4. Again, starting with all of the elements. So sodium 22.99 grams per mole. And there are 2 sodium atoms here, so I'm going to multiply that by 2. Plus sulfur has a molar mass of 32.07 grams per mole. Plus oxygen, and there's only 1 sulfur, so I'm going to just leave that as is, 16 grams per mole times 4. Okay, there we go. So let me add all of these up together. So 22.99 times 2 will give me 45.98 grams per mole plus 32.07 grams per mole stays as is, plus 16 times 4 will give me 64 grams per mole. And my total here is 64 plus 32.07 plus 45.98. This will give me 142.05 grams per mole. And just as we did earlier, we have percentage of Na here, percentage of sulfur here, and maybe off to the side I'll do percentage of oxygen. So the same calculations as before, so 45.98 grams per mole divided by 142.05 grams per mole times 100%, and that will give me 45.98 divided by 142.05 times 100 is 32.37. Now getting on to sulfur, 32.07 grams per mole divided by 142.05 grams per mole times 100%. So 32.07 divided by 142.05 times 100 will give me 22.58%. And lastly, for oxygen, I have 64 grams per mole divided by 142.05 grams per mole times 100%. 64 divided by 142.05 times 100 will give me 45%. Okay, so there it is. That is how you would find the percentage composition for all of the elements in Na2SO4.